the first question is asking us, it says the nth term sequence is n squared plus 5. List the first three terms of the sequence. Okay, so all you do for that, the first term, in place of n we've changed 1, so we'd say first term. So in place of n, we write 1, so 1 squared plus 5. So 1 squared is 1 times 1, which is 1, and 1 plus 5 is 6. For the second term, we would change it to 2 squared plus 5. 2 squared is 2 times 2, which is 4. 4 add 5 is 9. And for the third term, you do 3 squared, which is 3 times 3, which is 9, and on the 5 is 14. Okay, so if you were asked any term, if it said, can you find the 20th term, we'd do 20 squared plus 5. If you asked the 100th term, 100 squared plus 5. The next one says, write down the output. So write down this guy when n is the input. Okay, now this is even easier than when it's numbers. If it was a number, say you had 3 going into this, you'd say, right, 3, you'd add on 7, so then it's 10 going into this, and then you'd times by 4. So then the output would be 40. Now in this case, it's even easier. We've got n, so when we're putting 7 onto it, we're doing n add 7. So that's literally all we've got. We've got n add 7. Okay, that's my first step. The next thing that I'm doing, so I've got n add 7 going into this multiplied by 4. Now I'd be incorrect if I wrote times by 4. And the reason why is because it is this whole thing that's getting times by 4. This would suggest that I'm going to do BIDMAS and say 7 times 4 is 28. So it's the same as doing your number add 28. And you can quite clearly see here that when it was 3, 3 add 28 is not 40. Okay? So all I need to do to tweak that, to get it right, is stick in brackets. I'll do them in a different colour so they really stand out. And do brackets around there and there. Okay, that would be fine. Or I could have written 4n plus 7 like that. Or I could have written 4n plus 28. Okay? The next question says a recipe for making 10 fruit oat bars. Okay? So 10 fruit oat bars gives me all of those instructions there, blah, 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 blah. I'll worry about that in a minute. What is it asking me? It's asking me, she's making some fruit oat bars, complete the following table to show the quantity needed to make 150. So I need to try and find some link between 10 fruit bars, so I'll call that FB fruit bars, to get it to 150. So it's obviously an awful lot more than the 10. What I'm actually doing is I'm timesing by 15 because 15 times by 10, or 10 times 15, is 150. So basically, what I need to do is times every single ingredient by 15. Now, some of those will be easier than others. For instance, I don't expect you to know off the top of your head what 80 times 15 is. So what we would look at doing instead is we would look at doing some sort of splitting up of the 15 to maybe 8 times 10. And then, sorry, 80 times 10 and 80 times 5. 80 times 10 is 800. 80 times 5 is obviously half of 80 times 10, so it would be 400. Or I could have said what is 8 times 5, which is 40, and then add the 0 on from there. So that gives me a total of 1,200. So I need 1,200 grams of butter. Means I also need 1,200 grams of sugar because that was the same, so 80 and 80. The next one's doable in my head. 2 times 15, which is 30. And the next one probably isn't doable in my head. So we've got 130, so I'll write that over by here, 130 times by 15. I'm going to use exactly the same trick again. I'm going to do 130 times 10. I'm going to do 130 times 5. 130 times 10 is easy, you just add the 0 on, so 1300, and then times by 5 is half of times by 10, so it's going to be half of 1,300. Half of 1,000 is 500, half of 300 is 150, so put that together and you get 650. So put that together and we're going to get 1950, so 1,900. So 1,950 grams of porridge oats. The next one, again, 140, I would probably do exactly the same trick again. So I will do 140 times 15. It's not the only way to do it. There are other ways. You could maybe look and just say, well, that's only 10 grams more than the last one. So surely I just need to do 10 times 15 and just add on 150 to this, but I'm going to carry on doing the same method that I did before. So 140 times 10, which is 1,400, and then 140 times 5, which would be half of that, which is 700, add together, and I get 2,100. Okay, so 2,100 grams of that. And finally, 2 tablespoons, we've already done that, it'd be 30 tablespoons. Okay, the next part of the question says, when Linda makes 100 fruit bars, she buys a 2 kilogram bag of porridge oats. Find the weight of the porridge oats left over after making the bars. Give your answer in grams. Okay, so that's in kilograms. They want the answer in grams. Just be aware of that. That's things we need to just be starting to pick out before we go on too far. So if she made 100 fruit bars, that means she would have used how much porridge oats? Well, for 10 bars... 10 bars from above, so let me just zoom out a bit. 10 bars, we use 130 grams of porridge oats, so 130 grams porridge oats, okay? So for the next bit, for 100 bars, then that must be 10 times as much. So it must have been that she used 1,300 grams of porridge oats, so I'll just call that PO for short. Okay then, she bought a 2 kilogram bag of porridge oats. Now 2 kilograms, you need to know that kilo means 1,000, so it's 2,000 grams. So the answer to the question is, what is the difference between 2,000 and 1,300, i.e. what is 2,000 take away 1,300, which is 700. So my answer, 700 grams. Okay, I'm just going to write down from what I'm told from the previous page, which is 80 grams of butter. 80 grams butter is enough for 10 bars. Now, in this question, it says a recipe book states that 1 ounce is equivalent. That means it's the same to 25 grams. I'm going to write that down actually by here. So 1 ounce is equivalent. So 1 OZ. Sorry, I don't like my 1 there. I'm going to make it a bit better. 1 OZ is equal to 25 grams. It says, using this information, find out whether 5 ounces of butter is sufficient to make 20 fruit oat bars. Show all your calculations to support your answer. Okay, well I know that 80 grams of butter made 10 bars. So to make 20 bars, like the question's asking me, I need to have twice as much butter. I need to have 160 grams of butter. Okay, so that's my first fact. I need to be working with 160 grams of butter. Now, I know that 1 ounce is equal to 25 grams. I'm asked to get to 5 ounces. My shortcut to get there, I think I'm going to times both sides by 10. So I'm going to get 10 ounces would be the same as 250 grams of butter. And then I'm going to halve both sides. So half of 10 is 5. And I did that because that's the 5 that I want, is equal to 125 grams. So my answer is quite clearly going to be no, as 160 grams is needed and 5 ounces is equal to 125 grams. Okay then, so you're told this one has a scale of factor 3 and from the centre of O, and we're doing an enlargement. So they're my key bits. So I'm going to make something 3 times bigger. Enlargement would suggest it's going to get bigger, but if that was a scale factor of a half or something, getting half as big is actually getting like divided by 2. Now, people go wrong here all the time. They start drawing their shape 3 times bigger from here, so they start drawing something that looks like that all joined up, and that's wrong, okay? That's not what we're doing here, okay? What we are doing here is we are going to count. I'm going to zoom right in actually here. We're going to count to the nearest corner, which is this one here. So from my centre, how do I get to this corner? I go across once, twice. So I'm going to count that there, put a little blue dot on there to show it, and I know I've gone across twice. Now my scale factor, how many times I'm making that bigger, is 3. So I'm making it, instead of going across once, twice over here, 2 squares, I'm making it 3 times bigger from 0. So I count 1, 2, I'm already on 2, 3, 4, 5, 6. So the enlargement one should have been about, well, not about, but exactly here. Okay? So let's just check again how I got there. 1, 2 originally, back to the centre, 3 times as big. 1, 2, 3, 4, 5, 6, by there. Now, you could go and do that for every single corner. So we could go and find this corner here, how do we get there? This corner here, how do we get there? But for me, the smarter way of doing this is to say, in the original shape, this is a line of 2. I know in the enlargement it's going to be twice as big. And I've done the nearest corner, so I'm just working from this corner. But the one thing I don't want to deal with is any diagonal lines, okay? So, I'm making that line, because it is 2 along in the original, it now needs to be 6 along in the enlargement. So 1, 2, 3, 4, 5, 6 by there. And I'm just going to do dots at the moment. I'll join them up after. This line here is 1, 2, 3, 4 along. So in the enlargement, it needs to be 12 along. Okay, so I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 1 down from where my screen ends. And I'm probably going to have to do that again, annoyingly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There, that point there I make it. This line here is only 2 along, so it now needs to be 6 along. I'm going to zoom out a bit. And then also one thing I do know is that is in line with that, so I could maybe try and line it up there, but make sure it is a straight line. So I'm counting across 1, 2, 3, 4, 5, 6. So there. There. Now, I said before I don't like diagonal lines. Some diagonals are better than others, and this diagonal is much better than this diagonal. And the reason why is that it goes straight through the corner of squares. This one doesn't, so steer well away from that. Don't make the mistake of trying to use that one. Use this one. So it goes through 1, 2 squares directly. So I need to go through 6 squares directly. Okay? So I'm going to go 1, 2, 3, 4, 5, 6 to here. Okay? And then this line here is originally 1, 2, 3. So I need to go up 3 times that amount, so 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this square here. Colour that in. The next thing I'm going to do now is, I've done one final one that I've missed. I have not done this one. So this one was 2 squares along, so it now needs to be 6. So going all the way back up to the top here, 1, 2, 3, 4, 5, 6. So I need to fill that one in there. There. The next thing I'm going to do is just take out my ruler and join up all of those lines. So I'm going to try and do that while this is paused. It's a little bit easier, but I'll try and record when a line pops up. Okay, there's my first line, just nice and bold to make it really, really obvious. And the next one. And the next one. And the next one. And the next one. You can see I've done all the straight lines first. I always leave the diagonals till last, because they're the ones that are easiest to mess up. And the first diagonal. And the final one. So if I pinch and zoom out and have a look at it, that shape should look like it has been made 3 times bigger. Now the area will get massively bigger, which is another side of maths. But just check. This line here was 2, now it's 6. Scale factor 3. That means times it by 3. It means get it 3 times bigger. Okay, when you're looking at something called transformations, there are 4 transformations. Okay, the first one we just looked at on the previous question, which is enlargement. The next one is called rotation. It doesn't matter which order these are in as well. Rotation or rotational symmetry. The third one is reflection. They're all the really, really obvious ones that you've probably seen lots of times. And then there's a fourth one called translation. Okay, now, an enlargement has made the shape bigger. So if I look at this shape here, is that area bigger or smaller than that it currently is? And the answer is no. So I can quite safely say it is not an enlargement. Rotation says it's been spun around, and to me that looks like that could have been spun around, so I'm not going to discount that one yet, okay? The next one, reflection, means that it's looking back into itself, and again I can sort of see that if you rotate your paper by 90 degrees clockwise, so imagine that you turn your paper around like that, I can actually do it I think on this, but it might mess things up after. Yeah, there we go. I can do it there. It looks like that is reflecting into itself, but I'll undo that and turn it back. Okay, so it could be a reflection as well. And finally, translation means that it looks exactly the same. It's just been moved from one place to the other. Now that doesn't look the same because that point is now not pointing up anymore, so it's definitely not a translation. So for me, I'm going to go with the reflection, although it could have been rotated as well. I would have said the reflection's easier to spot. So all I need to do is look at these points here, here and here. I need to find where's in the middle of them. So where's in the middle of them? There. So my line would be literally just across here, just by there. Okay, and that line is going through the y-axis, and the value where it's going through the y-axis is at 1, so we say is y equals 1. So my definition that I'm going to put down here is reflection in y equals 1. Okay, bearings is our next C grade topic of the week. So in terms of if you've done your video notes for next Monday, then this is actually going to be really, really easy for you. Bearings, you need to remember key 3 things. Okay, first thing, they are always in 3 figures or in 3 digits, whichever one you want to call. So that's in 3 digits. X is 150. That means it's got 3 digits. Okay, they are always measured from north. So measured from north, and they are always measured clockwise. Okay, so in terms of what the question's asked me, it says the above diagram shows 3 points x, p and y which lie on a straight line. The bearing of y from p is 150. They've put that into the diagram for me. Find the bearing of x from p. So from p, that's the most important word that I'm looking for, the from p. So I'm here, I'm at p. Where's x? Well, x is here. This is where x is. Let me draw that a bit neater. X is up by here. So I need to measure from north, so up here, and I need to go all the way around because I measure clockwise. Now there's 2 ways of doing this. I know that on a straight line is 180, so I know that it is 150 degrees already, and then a further 180. So I just add them together. 0, 13, carry the 1, 3. So my answer is 330 degrees. Or I could have said it's just missing that little segment there. In a circle it is 360 degrees. 360 degrees, take away 30, because on a straight line is 180, so that must be 30, because 30, where is it, sorry? 30 and 150 make 180. And then I would get also 330. My personal preference is this method here. For this question, you will need a piece of tracing paper. It says rotate A through 90 degrees, so 90 degrees is also a quarter of a turn, clockwise about the origin. Okay, so the origin, that is, let me put it in a different colour, that is this point here. I'm going to zoom right in on it actually so I can draw it properly. This is the origin. This is what the origin is. It's where the axes meet. Okay, if I make that a bit thicker, that pen. Yeah, there we go. Okay, so that's the origin. Okay, but what we are also going to do, we are also going to draw a crosshair through that, because that will split up any rotation into 90, 180, 270 and 360 being a full spin. Although obviously I could have gone the other way around if I was going anti-clockwise. So 90, 180, 270, 360. Okay, so zooming back out, what I would do now, once I've drawn that crosshair, is I would trace not only the shape but also the crosshair. And then I'd read the instructions carefully. It says 90 degrees clockwise. So the way that the hands turn around a clock, if you think of a clock, there's the hands there, and there it's at 6 o'clock. They are moving around this way. So I'm going to do a quarter of a turn by here. Okay, so you'd need your tracing paper, you'd need to put it on, and then you'd have to physically do that. And it should look like this once you're finished. Yeah, it should look like this. If you had your shape up by here somewhere instead, I think it would be something like that. You would have accidentally gone anti-clockwise. Okay, then the algebra page. So we should be loving this page now. We've done a lot of work with this recently. So if I just zoom out and have a quick scan of the marks, we've got 3, 6, 8 marks here. So a big 8 marks. Okay, first thing that we're going to do, we're going to look for the smallest x here, and that is plus 5x. Two ways of doing it. We could either take away 5x from each side, and then we have an arrow down and balance it like an equation, or like a weighing scale. So we get 10x take away 5x, which is 5x, and that is then equal to 30. Or you could have said, let's take this plus 5x over the equal sign, and it will turn to a minus x, and you just don't write that one bit that side. Okay, it doesn't matter, they still work either way. So then another arrow down there. Get rid of the 5 in front of the x. That means you divide by that 5, because that really means 5 times x. So we're going to divide both sides by 5, so we get x equals 6. Okay, the next one, we are going to expand the bracket, so that 6 times is by the x, so we get 6x, and that 6 times by the minus 3, so we get minus 18 equals 42. The next thing we're going to do is we're going to put down an arrow, and we are going to add 18 to both sides. So adding 18 to both sides gives me 6x here. Basically, this minus 18 plus 18 cancels. And then 18 add 42, or 42 add 18, it gives me 60. So the next thing I'm going to do is divide both sides by 6, because that's the number in front of the x. How many 6's go in 60? 10, but you must state that x equals 10. Okay? The next one, you must expand that bracket first. So we're going to get 5a plus 3b. And then we already had plus 3a minus 20b. And what we're going to do is we are going to lump together any of the a terms. But when you're doing it like this, you must include that sign in front of the a. Okay? Anything else? Yeah, there's some b terms here. So anything with a b in it, I'm just going to put like a cloud around it, but include the sign in front of it. If you don't, you'll mess this up. And then 5a add 3a is equal to 8a, and then plus 3b take away 20b. So this is like me having 3 quid. I want to buy something for 20 quid. Obviously I can't afford it. I have to borrow some money. How much do I need to borrow? I need to borrow 17 quid, 17b. But because I need to borrow it, it's minus. That's one way of thinking of it. The other way of thinking about it is that you have a number line. You're on 3, you want to go down 20 places. So where would you end up? And again, same answer, minus 17. Again, another C grade topic of the week here, so we're quite happy with this. Express 792 is a product of prime factors. They're not the nicest numbers without a calculator, but it is even, so I know 2 must go into it. So 792 by here. How many 2's go into 7? The answer is 3, remainder 1. 2's into 19, 9, remainder 1. 2's into 12, 6. So my answer is 2 that we already had by here, and then 3, 9, 6 up by there. Now, what I should have done is I should have written out the first, or the more the better, but at least the first 6 prime numbers. So that's 2, 3, 5, 7. I'm going to cross that page number out so it doesn't confuse me. Not 9 because 3 goes into 9. 11, if you know up to there, you'll probably be fine. But the next ones are 13, 17. Again, I don't like my 13 there. Let me make that look a bit smarter. 13, 19, not 21, so 7 times 3, 23, yes, 25, no, ends in 5, 27, no, 3 times 9, and then 29. Okay, I wouldn't say you need to know any further than that. I'm going to circle the 2 because it is in my list. Anything in my list gets circled. This clearly wasn't going to get circled because it is even, so that means 2 goes into it again, so 3, 9, 6. How many 2's go into 3? 1, remainder 1. 2's into 19 is 9, remainder 1, and then 2's into 16 is 8. So it is 2 multiplied by 198. And again, 2 is prime, and then 198 clearly isn't because it's even. So 2 again. So 198. 2's into 1, 0. Okay, so then I'm looking in how many 2's go into 19, which again, I've already done that a number of times in the previous one. So it's 9, remainder 1. And then 2's into 18 is 9. So we're finally getting to the end of our even pattern. So it's 2 times by 99. And again, circle the 2. Now, 99 clearly isn't prime because its digits are repeated. If its digits are repeated, it has 11 and 9. So anything like 55 would be 5 and 11. 33 would be 3 and 11, etc., etc., etc. Now, this is prime, so I'm going to circle it, but 9 is 3 times 3. So then 3 and 3, and we are done. Now, a product of prime factors in index form. What I should really be seeing is I should see 2 times 2 times 2. So that's all of these ones counted for. 2 times 2 times 2. Next smallest is 3, then times another 3. So times 3, and then just the 11 left. So then times by 11. So that is equal to 2 cubed times 3 squared times 11. Okay? And it's this that will get you... it is this that will get you the full 3 marks. Your tree for getting at least 3 correct branches will get you 2 of those 3 marks. The next question says, write down the least positive whole number that 792 must be multiplied to make the result of perfect square. So I'm just going to write out what it was in indice form again. So 2 cubed times by 3 squared times by 11. Okay? We are looking for any of these numbers that have got odd powers. So this has got an odd power, so I need to multiply it by 2. This has an even power. Forget the number, just the power. That 2 is even, so that's fine. I don't need to times by that. And then this 11, this is really to the power of 1. So that is also an odd power, so I need to also times by 11. So I need to multiply by 2 then times by 11. And 2 times 11 is 22, so I need to multiply that by 22. This answer here is literally just a 1 marker. You'll get it or you won't. Explain why this isn't or is not a perfect square. And literally just because all powers are not even. That's all you have to say. If it said explain why it is a perfect square, all powers are even. But look, check them. That's an odd number. Even, even. Even though the 2's even, it's all to do with the powers or the indices. Okay, and to do this question, I'd probably draw each of these shapes. So a rectangle is like a long, stretched out square, isn't it, where the sides aren't the same. A parallelogram is, let me do it in a different colour, sorry. A parallelogram is a pushed over rectangle, okay? So really pushed over, but it's all falling in the same side there, okay? And then finally, a rhombus is a pushed over square, okay? So not quite as long and stretched out as mine was, okay? So let's tick off the ones that make sense. The diagonals are not equal in length. Well, if I looked at my rectangle, that there and that there would look the same. So that's not true. I'm not going to tick it for the rectangle. For the parallelogram, that side there's obviously really short, whereas this one is really, really, really long. Much, much, much longer than this distance here to here. So they are not equal in length, so I'm going to tick it. Same thing here. Look, really, really close together. Here and here, much further apart. So I'm also going to tick it for the rhombus. All angles are equal. In the rectangle, they're all 90 degrees, so I can tick that. Here, I've quite clearly got... I've quite clearly got an acute angle, and here I've quite clearly got an obtuse angle. So that's not true. Same here. Clearly acute, clearly obtuse. The sum of the interior angles is 360. Any four-sided shape has a sum of 360, so they're all going to get the tick there. Write down the name of the three-dimensional solid which has 4 triangular faces and 1 square face. That is what you see in Egypt, and we call it a square-based pyramid. The name of the three-dimensional solid which has 2 triangular faces, so 1 there, and then 3 rectangular faces. So again, think bars of chocolate at the airport going to Egypt to see the pyramids. That is a triangular prism, okay? Do not write down Toblerone, that's just a chocolate. The shape is called a triangular-based prism. Okay? Again, another C-grade topic of the week. So, we know how to do these. We split here, midpoint. Now, usually we had a calculator, so that means the numbers can't be too bad. Under midpoint, we grey out so we don't accidentally add up. Middle of 0 and 8, 4. Middle of 8 and 16, 12. Middle of 16 and 24 is 20. New column. This column's called midpoint times frequency. 4 times 25, so double of 25, 50, double it again, 100. 12 times 60, don't know. 12 times 6, 72. Add a 0 because there's a 0 there, 720. And 20 times 15, don't know. 2 times 15, 30. Add a 0 because there's 1 here, so 300. Total them all together. It says here 100 fish were caught, so equals 100 there. That should add up to 100. You can check if you want. 25 and 15 make 40. 40 and 60 makes 100. Here, add up. 720 add 300. Forget the 20, we'll add it on in a moment. 700 add 300 is 1,000. Add the 100 is 1,100. Add the 20 is 1,120. So using number bonds to help me there. Find an estimate for the number of fish that were caught, or the mean length for number of fish. So that is the total. You don't need to write this down, I'm just writing it down to help you. The total of the MP times F divided by the total of the F, which is going to be 120 divided by 100, which is, well, it's going to take a 0 off, it's going to be 11.2. And remember, your answer should be between 0 and 24. Frequency polygon, that's the key word here. You need to pick that out, and you need to know 2 things about it. It is a line graph. It is plotted at the midpoints. Okay, that's what a frequency polygon is. So I need to know the middle of 1 to 10. Now, it's not as obvious as you'd think. You'd think it's 5. It's not. You need to do 1 add 10. 1 add 10 is 11. You then need to halve that answer, which is 5.5. Okay? And this follows in a similar tact here. This is 15.5, 25.5, 35.5, and 45.5. Okay, so just be careful. It's not 45. You'll lose one of those 2 marks, and that's a pretty nice 2 marks, this one. So 5.5 and 16. So I'm going to go and plot 5.5, so I'm looking at 5 more or less, and then I'll worry about the 0.5 in a minute. And then 16, oh, I need to go and work out the scale. So that jump of 10 is taking me 5 little squares. You can see here, again, if I zoom in, you can really see it. 5 little squares, 1, 2, 3, 4, and then 5. So I'm going to do 10 divided by 5, which I know that is 2, so that is what 1 little square is. One little square. Okay? So, next I am going to plot 5.5 and 16. So, like I said, I'm coming to 5 first of all. 16, here's 10, 12, 14, 16, and then I'm going to go just ever so slowly, just over from the 5 line. Okay? Next one, 15.5 and 50. So, I'm going along the 15, all the way to 50, and then I'm going that tiny little bit over there. The next one's 76 and 25.5, so on 25 there's 70, 72, 74, 76, and a tiny bit over, so there. Then 35.5, so I'm on 35 and 10, come a tiny little bit over. And then 45.5 and 8, so 1 down, because that would be 2 back. And then it's just a case of using your ruler to join up these points here. Okay, bit of a nasty question, but it is doable. So it's just substitution, this one. So referencing here, y is 3x squared minus 2x. So that is going to be 3 brackets minus 2 brackets minus 5. What is going in? Well, 1 is what x is. So 1 goes in there and there. What is 3 times 1? That's 3. What is 2 times 1? That's 2. And take away 5. Think of it as money. Got 3 quid. Spend 2 quid, you're left with £1. Spend another £5. You can't. You must have borrowed 4 quid. So you're down £4. You're minus 4. Okay? So then I think on the next page we need to draw that graph. Okay? So minus 2, 11. Now I'm going to have to be going back and checking those ones. So first point I'm plotting here, minus 2 and 11. I do it with a little x. Then minus 1, 0. So that is literally on the axes there. Now 0 minus 5. So we're in between 0 and minus 10. And then 1 minus 4 there. So then 2 and 3. 3 and 16, and 4 and 35, so by there. Okay, now a squared graph is a curved graph, so I'm going to try my best here, but yours will look better than mine. You freehand draw it so it curves like this. Okay, that's not too bad. Take that. And looking up above, it said draw a line of x equals minus 1.5. So x equals minus 1.5. So put your finger on the x-axis. Here is the x-axis. Find where it is 1.5. Here's 1, here's 2, here is 1.5. This is where it is 1.5 here. That is x equals 1.5. So that is all of these points through here. So there's only one. There's only one point there. So it says write down the coordinates of the point where the line intersects that. So its coordinates, I've gone across to 1.5. So that'd be comma 1.5. And I haven't risen at all. I'm on 0. So 1.50 I make it.